Well, I'd like to thank you all for joining me today, our team, Sinisi Solutions. We're over in booth 1308. And I wanted to talk about something real important. If there's any data center managers, healthcare, schools, universities, what we protect really is you. And we do that by protecting your power sources and your transformers, your substations, your fuel storage, and giving your businesses resilience. So it's important to us to kind of frame this out a little bit first and then talk on the educational side a little bit about how we do what we do and save you money in your insurance costs. So, as you can see, we work with a variety of facilities. Some of them are occupied, some of them are not. We started way back in the day protecting people, and now we're protecting things like energy storage, emergency systems, and we're doing it typically through providing protection to the large transformers and substations that provide power to the facility. So you'll find transformers, when they fail, you could walk up to a transformer with a match and you're not going to light it up. Right? When it fails internally, and it fails with an explosion. That explosion throws shrapnel, ball bearings, ceramics, up to about 250 feet with the force of a .44 Magnum. It's measurable. It's an implosion and then a force. Additional to that, not only the explosion and the shrapnel, you have a high temperature fire. That's an extended high temperature fire to deal with. The impact of those failures typically are the collateral damage that a transformer fire creates. It damages the transformer next to it, causes loss of business interruption. Transformers could take months and months to a year, to years in some cases, to replace. Not an easy piece of equipment to get your hands on. Damage to building, operations, downtime for your operations. You have no power. If we shut the power off in here right now, NFMT would have no business. How's the power getting here? Through a series of transformers, the electrical grid, and providing resilience to the electrical grid is what we're about. The proximity of your transformer to the building, to the schoolyard, to your other transformer is really, really important. We're dealing again with a force and an explosion. Many instances near schools, university campuses, where transformers fail and create building fires or collateral damage. So it's not just industrial operations, but we're going to talk a little bit about the impact of insurance and if you did lose power and why the insurance companies have identified transformers and power that's coming into your facilities as a critical asset. The amount of money lost and property damage without a transformer fire barrier system, easily you can see big numbers. 13 months of downtime on average. These are factory mutual numbers, okay? These are talking about all the transformer failures. This is what we're feeling. With fire barrier systems, these numbers drop. And this is what you're rated on for your insurance. For your catastrophe insurance, for your business and continuity insurance, and even pollution insurance will show you. But you can see this transformer, which is a typical old transformer, on fire, 6 to 8 hours, throwing ball bearings and shards. If we could protect you from that failure, protect your business, your hospital, your facility, your schoolyard, you're going to achieve lower insurance rates. There's something called a risk mark score. Transformer fire barriers raise your risk mark score, thereby lowering the impact, lowering your insurance rates. Environmental insurance, if you guys are near, and ladies are near waterways, creeks, lakes, if you have a sprinkler system on your transformers, not going to do well for you. We do a lot of work around transformers and waterways. There's 3 methods for compliance for transformer fire barriers, all right? You could use foam. Foam is outlawed. It's a carcinogen. The firefighters are suing all of the foam manufacturers now, and foam systems are coming out of facilities. Typically, you remember the big shaving cream foam, AFFF, aqueous film forming foam, no longer can be used. The second method, which is the most common, is the water sprinkler deluge system. Environmental nightmare. PCBs, oil, thousands and thousands of gallons of water, and it doesn't even put the fire out. It's a transformer, it's a hydrocarbon fire. You're wasting your time. This system here is on the Wilson Hydro Dam, provides most of the power to Alabama. Those couple transformers, if they were to fail with the sprinkler system, you'd have a river full of hydrocarbons. You can comply with NFPA, with fire code compliance, with safety compliance, environmentally sound with separation and compartments. How do you do that? Anyone familiar with the NFPA standards? You kind of work with those, I'm sure. You see them in different areas. Well, this was not maybe as well known, but it's a real important one for me. And it literally tells you how big to make the fire barrier. The standard's a couple pages long, so the rating and all the other good stuff. But really, this is the crux of the whole thing. If you have a transformer near a building, you probably, if you're within 50 feet, you're required to have a fire barrier. Many of the new properties, everything is kind of squished together. The architects don't have as much room. They put things in smaller places. They would wind up next to buildings. Senior care centers, I can't tell you how many times, long-term care facilities. Transformers and generators are right next to the building. Obviously, you can see we have some idea also if the transformer is further or closer away, the wall could be bigger or smaller, okay? It has to protect from explosion, so we use what's called line of sight. We simply just look at the explosion line and put a barrier, a catcher's mitt in the way. So when we're protecting transformer to transformer, which is almost as just important because typically one's a spare and one's a primary, we know how big and how tall to make the barrier. That's what you get from us, stamp drawings saying, look, this is what you're going to do, and that's what we give your insurance company. FM approves this, and this is your method. No chemicals. The barriers last for 50 years. They're galvanized. They're modular. They come up, they go down. Line of sight. That's a 765 kV transformer behind there, probably one of the largest in the country, maybe not the world. That's what we're talking about. Being able to protect people, places, and things, using shielding, using guarding, using barriers, and line of sight. Zero visibility. We provide not only fire explosion, additionally we do ballistics. So it's not only protection from within. If you have a transformer sitting out on the highway, we'll protect it from the outside. We have companies that use our barriers to protect from storm damage. We have a barrier installed in Antigua, protecting from 150-mile-an-hour storm winds. If you get a 2x4 coming 150 miles an hour, that's going to take your transformer down. We protect against that. We're impact rated. These are really critical infrastructure protection systems. You just don't put them up indiscriminately. They're not noise barriers that you see along the parkway. They're fire rated, explosion rated. Typical strategic fire barriers located in places that protect line of sight, protect people, protect the equipment. 2 standard separation methods. Anyone in the electrical end will really, 3 phases of power are typically going through an industrial or large facility, phase 1, phase 2, phase 3. Well, you want to protect if one phase fails, you can always run on 2. So you separate the phases with a fire barrier. That's resiliency. That will allow the plant, the hospital, the school, whatever it may be, to continue to operate while you make some repairs or a replacement, whatever it may be. But this transformer failing is going to blow shrapnel, fire, flaming liquids, and take out the other two transformers. That's what you do not want to happen. You want to have separation and containment to assure that one transformer failing doesn't affect the other two. A lot of times, it's funny, I'm on job sites where the transformers are 50, 60, 70 years old, never been turned off. They're running a facility, never been turned off. And then they put a brand new one next to it. And the guy who's been running the one for 50 years, you say to him, look, which one do you feel more comfortable with? This old clunker for 50 years or this brandy new system we got? And I will tell you, 9 out of 10 of the old timers will tell you, I'm not going to be here the day they start the new one up. Because the new ones fail just as much. The old one's been running for 50 years. Yes, it requires protection, it requires compliance, it has maybe other issues, but even in new installations, you're going to find the transformer, people that sell you a transformer or work with you, if you have new construction, they're going to be required. These are new, and they're required as part of the job now. So there's not a grandfathering. This is something that you really need to think on if you're doing new construction. Benefits, 50% less property damage, 80% less body injury, no downtime, recorded savings in your insurance. Workers are protected, critical assets are shielded from collateral damage. We can't put out a transformer fire, all right? You could stop it, you can monitor it, you could see what's happening, but if it goes, it's going. You wait until it burns, you stand back. That's what we're looking to do. Contain, protect. Couple more slides, just to get you through. If there's any questions or anyone has any other thoughts, this is not just for transformers. We're doing a lot more industrial facilities the last 5 or 6 years, protecting energy storage systems, protecting battery backups, generator fuel storage, your local power supply. We have clients in the steel industry, they have substations right on their plant, right on the job site, all right? Fuel lines for generators. I know I mentioned that to a couple people out in the show and they turned a couple heads because now the generators, everyone puts them on the roof because they don't want them to flood out in the basement. But they got to put the fuel somewhere. So they put it in a fuel tank underground and they got to pump it to the roof. So how do you get the fuel from the basement to the top of the 30-story building? Through a fire-rated shaft. Again, fire barriers and protection. So people, places, and things, if it's wiring and cabling, we had one municipality come here. We do several municipalities. So if you're in a municipality where you have one substation that provides power to your facility, say you run a long-term care facility, you may have one transformer in that whole community. Go to your power company and say, look, how are you guys protecting me? What kind of resilience? You can have all the power you want on site. You need that substation. You know your generator is going to last only so long. You know you're on limited lighting, you're on limited fire protection, limited alarm systems. There's a lot that goes into once that happens. So if you go to your utility and say, look, utility, protect me. I'm paying the bill and you're supposed to be in compliance, they'll pay for the fire barrier. This is up in Narragansett, Rhode Island, where we have battery storage and transformers. This was motivated by the industry in the area that said, look, you know, we're putting our company here, we have our hospital here, and if your substation fails, we have nothing. So you can work with your utilities. Why does a facility need a fire barrier? If your transformers are near a building, if you're standing on the university campus and you can see a transformer, you need a fire barrier. In New Jersey, we've got a series of schools that have transformers next to them because the utilities always use the cheap land next to a school. The kids tie their bicycles up to the chain fence. We went to the utility. We're working on fire barriers there to protect the school from the fire barrier, from the transformers and substation next door. So if you have a transformer near a transformer, you have two phases of electric. You need to separate those. If you have a transformer exposed to the public or a roadway, people walking by the sidewalk, sometimes that happens, or energy storage. We're just doing a bunch of Tesla megapacks now that are put right next to a sidewalk. So if it's batteries or transformer storage, control rooms, transformer in a parking lot, we get calls all the time, oh, they're putting in these EV charging stations in our company. And we get there and there's a transformer sitting right there. And I'm like, look, you're worried about this EV charging station. What about this big transformer sitting in your parking lot? So it takes your eyes in the facilities end to be able to really look at your facility, look at the pinch points, understand the importance of losing power. If you lost power, what's going to happen to us? And then look back at what I guess called the roadmap. You know, if it goes through your facility, through your switchgear room, to your substation, or out to your utility. We build buildings. If you have an electrical substation, a small power plant, a control room, our materials are very unique. And if you please could come to our booth later, we'll give you some little magic lesson on them. But they're very unique. Our fire panels are impact and fire rated. All types of configurations. Wall coverings for switchgear rooms. Separation, we do a facility that has a 50-year-old scotch or something, whiskey and wine. And they, to get insurance, needed to separate their areas. You know, they were in old rooms 50 years ago, and now the fire department came in and said, well, now it's 50 years old, it's much more money in the inventory. Went in and recoated the walls and brought ratings up with our FireBarrier and impact materials. So there's a lot of options, a lot of thoughts. If you're any of you involved in mechanical, electrical, or plumbing, or controls, we provide fire impact boxes, a big seller in storm areas, if you have outdoor controls. These are under New York City, in the Manhattan, in the transit system, protecting, notice only some of the cable, the important stuff, moving through there, alarm systems, again, built out of our materials, ductwork, fire barriers, areas that are critical infrastructure. Piping. So with that, I have a really slide or two more, and this is really our summary slide, so I don't know if you have any real questions or any thoughts, but I'm happy to answer them, of course, but really exposure to loss. You could bring this as a project to your team, to your insurance team, to your risk management team. I know they're always looking to do two things, save money and increase safety. We're on the annual report in some companies because the companies are proud to say, look, we protected our people and we also protected our business or protected our hospital or our long-term care facility. So remember, please, we lower insurance costs, we raise your risk mark score just using fire barriers, no chemicals, no electric, just our fire barriers. Environmentally compliant, you don't have to worry about leaching. These are 50-year installations, they don't rust, they don't absorb mold, they don't absorb mildew. And that's some of the magic we could show you back at 1308, our booth. And we're seismic compliant. I don't know if any of you are working in California. We had a utility come here from California yesterday. We're big in California because our barriers absorb impact and you can't put up a block wall, a concrete wall. It'll fall down. Our barriers are made to stand up. Pollution insurance, I can tell you, the pollution insurance goes away. You have no groundwater capability, no loss to, being able to spray water or foam anywhere. You have basically an air pollution violation at the end of the day. It's about $5,000. You write the check and you're done. The stuff disappears into the air. Sounds a little crude, but you know what? We have a couple utilities that are working on their 30th or 40th year of a spill cleanup from a transformer fire because it was next to a creek that had like oysters in it or something. It gets crazy. So control and containment. Meeting NFPA, if you need to get your project approved, sometimes you need a firewall or multi-tenant building. OSHA compliance, code compliance, we're underwritable, 100% underwritable from Factory Mutual. Please remember that. That's how you pay for what we do. 50-year installations, family company, and we're in 1308. So there you go. I think I got it. I hope we got it across a little bit, and I thank you all very much for joining us today. This was a real good thing.